Now, in this video, we will going to discuss about the types of stresses. So the types of stresses, first one we're going to consider the normal stress, which is going to be either tensile or the compressive stress. And then we have shear or the tangential stress. And number 3, the bearing stress. And number 4, the bending stress. And number 5, twisting or torsion stress. Similarly, we have the types of strain. We have the tensile strain, we have compressive strain, then we have the shear strain and the volumetric strain and superficial strain. So first we're going to take up the normal stress. So if the internal forces and the corresponding stresses act in a direction perpendicular to the surface, it is known as the normal stress or the direct stress. Normal means always it is acting perpendicular. The surface area, the load acting on the member will be always perpendicular to the surface area. So that is what is the normal stress. The normal stress again is of two types. One is the tensile stress. If the load applied is tensile, then the compressive stress, if the load is applied, is of compressive in nature or compressive load. So first we are going to take up the tensile stress and the tensile strain. So what is the tensile stress? When a body or section is subjected to two equal and opposite pulls, and if it tends to pull apart the particles of the material, causing the extension in the direction of application of load, then the load is tensile load and the corresponding stress induced is known as the tensile stress. So that means on a body or a section, if two equal and opposite pulls which are applied on the body on either side, and then what happens in the internal particles will going to pull apart, causing the extension of the member in the direction of application of load. So such a stress, what we are going to stress, or the load applied is tensile, and the corresponding stress what you will going to get is the tensile stress. Now we are going to consider the diagram or a figure when a load on the member, when a body or a specimen which is subjected to axial pull, which is as shown in the figure with P. Consider a section XX, which is as shown in this figure A. So when you consider a section, what happens? The material will going to be deformed, or the material going to cuts into the two pieces. One is on the left hand side and the other one is on the right hand side. If you are considering only the left hand side alone, now the P is pulling from the direction from the right towards the left side, which is the P which is applied. So the body will not be in equilibrium condition because the load is applied along the left hand side. So due to this, the member will try to move towards the left side. But according to the equilibrium condition, what it says, if you have the magnitude equal to the applied force, then the resisting force will be able to withhold the external force applied, then the body will be in equilibrium condition. So when you are considering this as the first member, this member 1 will be equilibrium condition when you have the resisting force which is P dash, whose magnitude will be equal to that of the applied load which is applied from the right towards the left side. So now the body is in equilibrium condition such that the resisting force P dash will be equal to P. Similarly, now we are considering to the second member, which is the member 2, which is on the right side. So as the member is applied with a load P, which is moving from left towards the right side, now the body will not be in equilibrium condition. If the body has to be in equilibrium condition, and there should be a resisting force which is P dash, whose magnitude will be equal to the applied force P, then the member 2 will be in equilibrium condition. So that is what he has shown here. where the member 2 will be in equilibrium condition such that P will be equal to the resisting force P dash. So on the combination, if you apply two together, what happens? When the applied load P is applied from right towards the left side, you're going to have the resisting force from the right towards the left towards the right side, which is P dash here. That is for the member 1. Similarly, for the member 2, when the load is applied from the left, from the point towards the right side. So in order to keep this in equilibrium condition, the member 2 will going to exhibit the resisting force whose magnitude will be equal to the applied force P, which is P dash, which is as shown here. So now the entire body, when it is put together, will always be in equilibrium condition. Now, this is what we have explained in the consider a section XS, which is as shown in the figure A. The portion left on this section is in equilibrium if the resisting force P dash is equal to applied tensile force, which is again as shown in the figure B. Similarly, the portion right of the section is in equilibrium if applied tensile force P will be equal to the resisting force P dash, which is in figure C. So mathematically, how we can write, let P will be equal to the applied tensile load and P dash is the resisting force. Then A is the cross-section area of the bar. Then what is the tensile stress? The load by the cross-sectional area or the resisting force by the cross-sectional area. So what is the resisting force? That is, resisting force is nothing but the applied tensile load divided by the cross-sectional area, where tensile stress sigma will be equal to capital P by A, where P will be equal to P dash. Now we will go to get the tensile strain. So when a body is subjected to two equal and opposite pulls, that is tensile load or a force, it causes the internal material will try to pull out the material, thereby the extension will going to take place, or it causes the extension or increase in length of the bar in the direction of applied load. So when the ratio of increase in length by the original length, or when the ratio of increase in length to the original length is known as the tensile strain. That is, tensile strain is defined as the extension per unit length. So here, if you are considering a figure, you can see that AB is the tensile test specimen when the two equal and opposite forces is applied on the body. The body will going to elongate from B to C. The elongation will going to be the delta L, and small l is the original length of the member. So here they consider a bar which is subjected to a tensile force or the tensile load or the force P as shown in figure. Let AB be the original length of the member, which is equal to L. AC is the final length of the bar after the application of load P, or after the application of tensile load P, because we are considering the tensile strain. So what is the extension of the bar? The extension of the bar BC will be equal to the final length minus the original length. So what is the final length? Final length is nothing but AC minus the original length is nothing but AB. So then the difference between these two will going to be BC, which is equal to delta L. So what is the tensile strain? Extension or increase in length by the original length of the member, which is equal to tensile strain epsilon will be equal to delta L by L. Now we will going to consider the compressive stress and strain. So what is the compressive stress? When a body is subjected to two equal and opposite pushes, and it tends to push the particles of the material near causing the shortening of the member of the shortening in the direction of application of load, when the load is compressive load, and the corresponding stress is known as the compressive stress. So here if you see, consider the section A, when the member has been having the pushes, that is both towards each other. So consider a section, when you are considering the section here. So the member 1 is not in equilibrium condition. If the member 1 has to be in equilibrium condition, the load applied P here, which is from left towards the right side. So in order to keep this, the body tends to move towards the right side. In order to keep the body in equilibrium condition, you need to have a resisting force which is acting on the member such that it is moved from right towards left, which is as shown here, which is the resisting force. If at all, if you want to keep if you want to keep this body in equilibrium condition, the resisting force should be equal to the applied force P. Similarly, when you are considering the second member, that member 2 is not in equilibrium condition because the load is applied from the right towards the left side here, P. So the body tends to move towards the left side. In order to keep this body to be preventing movement, though that means it should be in equilibrium condition, you should have a resisting force P dash, which will be acting from left towards the right side, whose magnitude should be P dash will be equal to P, which is as shown in this figure. Similarly, so this is the combined effect of both the members when the load is applied. So you will going to get the load which will going to be of the compressive in nature. So that is what we have explained here. Figure A shows a bar of subjected to compressive force of load P as it tends. Consider the section. The portion left of the section is equilibrium condition if the resisting force P dash is equal to the applied compressive force P. The portion to the right of the section is in equilibrium condition, then if the resisting force P dash will be equal to the applied compressive force. Similarly, the resisting force per unit cross-sectional area is known as the compressive stress or the unit stress. Let P is the applied compressive load, P dash is the resisting force, then A is the cross-sectional area of the bar, then compressive stress sigma will be equal to resisting force by the cross-sectional area, applied compressive load, that is nothing but applied compressive load divided by the cross-sectional area, which is sigma will be equal to P by A because P is equal to P dash. Similarly, you have the compressive strain. When a body or a bar is subjected to two equal and opposite pushes, that is compressive load or force, it causes shortening or decrease in length of the bar in the direction of application of load. The ratio of decrease in length to the original length of the member is known as the compressive strain. So compressive strain is defined as shortening per unit length. So if you have the figure wherein you have AB is the original length and AC is the final length and BC is the compressive length. So AB is the original length which is given by L. AC is the final length of the bar after the application of compressive load. The shortening of the bar will be BC, which is AB minus AC, which is equal to BC, which is equal to delta L. So what is the compressive strain? Shortening or decrease in length by the original length of the member. So compressive strain will be equal to epsilon delta L by L. So from the next video, we will going to discuss about the bearing stress. Those who like, if you like this video, please subscribe to my channel. Thank you.